Alright, class, welcome to another episode of Brand Academy. As always, my name is Bran, I'm Mr. Wynn's twin brother, and today we're on chapter 10-5, tangents, okay? So the word tangent, you might be thinking, oh, it's from SOHCAHTOA. The short answer, yes and no, okay? It's yes and no. For our sake, it's going to be no for now, okay? So in general, the word tangent, the Greek word, it's a Greek word that means to subtly touch, right? So like if we're in class right now, I'll probably make a joke saying, hey Jacob, don't tangent Jessica, right? Or vice versa, hey Jessica, don't tangent Jacob, right? So to subtly touch, in terms of mathematics, it specifically means to intersect a point or intersect something at exactly one point. In this case, we're on chapter 10, so we're talking about an intersection of a circle. Okay, so a quick example, boom, circle. And a tangent line, okay, a tangent is basically a line that touches the circle at exactly one point. Okay, so boom, that's that one point it touches that. Okay, only 1 point, okay, not multiple points, exactly one. Okay, can I draw another tangent here? Boom, you bet I can. Bam, tangent. Okay, so these are what we call tangent lines. And this specific point right here, we call it the point of tangency, okay? There are important relationships involving tangents. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. Okay, so for example, let me draw another circle here. Boom. Oh, shoot. Oh, can I move it? Yes. Okay, let's take a look here. Bam. So this line here, this red line right here, boom. This is now called a common tangent, okay? AKA, it's just shared between two circles, okay? A common tangent, that's what it is. Now here are your two theorems, okay? Here's theorem number 1. A line is a tangent to a circle if and only if it is perpendicular. If you want to save some lead, you can just do the symbol perpendicular to a radius at a point of tangency. So let's look at our official example here. Take a look at that. Okay, so if RS is perpendicular RP, let's identify that. RS and RP. Boom. Okay, if it's perpendicular, then RS is tangent to circle P. Okay, it touches at exactly 1 point. Or vice versa, if SR or RS is tangent to circle P, then RS is perpendicular to RP. Okay, boom. You see that there? So basically, a radius that connects to a point of tangency right here will always form a perpendicular angle. And guess what we can create now with this perpendicular angle? Boom, a right triangle, okay? A very powerful shape. Okay, so just keep that in mind, okay? Like, again, triangles is always going to come back to us. Here's another theorem. Theorem number 2. If two segments from the same exterior point are tangent to a circle, then they are congruent. Okay, so let's look at the segments now. Okay, look at SR and ST. Okay, SR and ST. Okay, are they tangent to the same circle? The answer is yes. They're tangent to circle P. So if they're tangent to circle P, then that means SR is congruent to ST. Okay. Oh shoot, sorry. So basically this is saying SR right here is congruent to ST. Okay. If they are tangent to the same circle. Okay. And keep in mind, exterior point, the word exterior means like exit, right? Outside. So this is the outside point again. Okay, so any point you put on the outside. I can make up a new one if I want, right? Boom, let's call it point B. And let's say I want it like right here. Boom. Boom, and and here. Okay, if I do this, okay, then these two segments right here will be congruent. Okay, some nice visuals. All right, let's do some examples here. Okay, we'll go level 1 example first. Okay, AB is tangent to circle C. Okay, it hits at this 1 point. If it's tangent to circle P, that means the radius and that point of tangency forms a right angle. Okay, so boom. Now, we probably want to use Pythagorean theorem here. So what is DC? How do we know what DC is? DC is also the radius, right? So boom, that's also 8. So now we can use Pythagorean theorem. Keep in mind the hypotenuse is your C squared, okay? So it'll be x squared plus 8 squared equals 8 plus 9 is 17 squared. Boom, boom. 289, little math magic. X would equal 15, okay? Make sure you guys practice with your calculators. All right, I'll probably do, I'll do example 1 and then you guys can try the other 2, okay? So example 1 now, this is theorem number 2, okay? So keep that in mind. This is theorem number 2 we're gonna be doing. So assume that the segments appear to be tangent are tangent. Okay, so boom, this hits it at 1 point, hits it at 1 point. If this is true, what can I do with these two? CB is congruent to CD. And the reason is because of theorem number 2 here, okay? They're both tangent to the same circle, so they're congruent. So x plus 3 equals 7, x equals 4. Boom, magic. Okay, please try 2 and 3 on your own, okay? So please pause the video here. All right, let's take a look here. Number 2 is actually very tricky. I should have warned you guys about that. But anyways, the easier way to do it is this right here. Okay, so essentially, yes, this is here is 15 because also a radius. 15 plus x squared, right? That's your hypotenuse. Again, hypotenuse, the longest leg, opposite the 90. So here's a tricky step here. You can actually just, once you like square everything, add it up. If you take the square root of 1521, if you take the square root of that, you actually get 39, a nice clean number, and then you solve for x. If you didn't do that, you guys probably did it this way right here. So I basically just took this step, okay, and moved it down here. So I FOILed this out. When you FOIL out 15 plus x quantity squared, you get this. And then I subtract 1521 over. Now I have this here. And then you do your x method. And obviously, we all know 54 times negative 24 equals negative 1,296. And conveniently adds up to 30. And then you do your factoring here. And x equals 24 as well. Okay, either or, they both work. Don't worry too much about it. That's a pretty tricky thing, so I won't put that on the test. Number 3, this is like a proof type of question. It's letting you know right now that, hey, this is 27. Is QR going to be tangent? And now it can only be tangent if and only if it is perpendicular to the radius. So is this going to be perpendicular? AKA, does it form a right triangle? Okay, and then we're going to see right now if it works out or not by plugging in the Pythagorean theorem. Keep in mind, I keep putting a question mark here because we don't know if they're actually equal. And in the end, they don't equal. So the fact that they're not equal by using the Pythagorean theorem, it is not a right triangle. Thus, QR is not tangent. Okay. All right. Please watch part 2 of the notes. Okay, we have one more theorem to learn, and that's it.